Welcome to the PACCAR Powertrain Driver Series. This video covers how to get the best reliability, best performance, and best life expectancy out of your PACCAR MX engine and its aftertreatment system. Today, all the major systems and components on a commercial truck are monitored by sensors and computers to make sure they operate safely and efficiently. This is especially true of the engine and the aftertreatment systems. The aftertreatment system was added in the 2000s in response to emission mandates by the Air Resources Board and the Environmental Protection Agency. Unlike your passenger car, a commercial truck is considered a workspace, and as such, it becomes part of the responsibility of the driver to maintain the aftertreatment system. There are three main sections in the modern diesel aftertreatment system. These are the diesel oxidation catalyst, usually referred to as a DOC, the diesel particulate filter, usually referred to as the DPF, and the selective catalytic reduction unit, or SCR. As it operates, the DOC performs several tasks. It reduces carbon monoxide emissions, it reduces gaseous hydrocarbon emissions, it also produces nitrogen dioxide for the operation of the SCR. But the most important thing it does for today's discussion is generate heat, and lots of it. So what can you do to increase the life expectancy of your diesel oxidation catalyst? The DOC uses leftover fuel from combustion, as well as fuel from a source known as a hydrocarbon doser, for the generation of heat. Sulfur, commonly found in fuel that is not meant for trucks in North America, can quickly poison the DOC, and that has a detrimental effect on the entire aftertreatment system. When the controller detects a problem with the DOC, it will set a trouble code and either turn on the check engine light or the malfunction indicator light, or both. PACCAR recommends the use of CJ4 or CK4 oil in their engines. These oils have a low sulfur content and prevent the aftertreatment from being contaminated by sulfur from engine oil. Some of the traditionally used oil and fuel additives can harm the DOC and the rest of the aftertreatment system. Check with the additive manufacturer before using it to see if it is compatible with the aftertreatment system. Even contaminating the fuel with substances like diesel exhaust fluid, for instance accidentally putting DEF in the fuel tank, can cause damage to the DOC. Next is the diesel particulate filter. It is designed to trap soot, smoke, and other particulates carried by the exhaust gases. But like any filter that traps particles, eventually the filter will begin to restrict. Most of the time this is not a problem. Heat from the DOC contributes to a catalytic reaction that continuously reduces soot to ash. Under some driving conditions, the engine and the DOC do not produce enough heat to allow this reaction to happen continuously. This will cause the DPF to slowly become restricted. Sometimes the driving conditions will change abruptly, and the regeneration will terminate. Too many incomplete regenerations can affect the efficiency and life expectancy of the DPF. Short and repeated drive times at less than highway speeds can result in incomplete regens. Extended idling, stop-and-go traffic, and low load conditions can cause reduced heat in the aftertreatment system. This can result in a need to perform a parked regeneration. The engine should be at low idle. The parking brake should be set. The DPF warning light should be on or flashing. The coolant temperature should be at operating temperature. The throttle, brake, and clutch should not be applied. The PTO should be disengaged. The transmission should be in neutral. The cruise control switch should be off, and the engine brake switch should be off. If the driver ignores the warning lamp, it will begin to flash. If the driver ignores the flashing light and the DPF continues to be restricted, then the check engine light will come on, trouble codes will set, and the engine will be put into a derate mode. At this point, the driver can still perform a stationary regen and restore the truck to full operating condition. When the soot level in the DPF reaches full capacity, the engine will derate further. The stop engine light will come on, and a chime on the dash may activate. At this point, the driver can no longer regenerate the DPF. The truck may have to be towed to an authorized PACCAR dealer or service center to have it restored to normal operation. The last component in the aftertreatment system is the Selective Catalytic Reduction Unit, or SCR, and in some ways, this is the most complicated part of the aftertreatment system for the driver. The job of the SCR is to use an injected solution called diesel exhaust fluid, or DEF, to lower NOx emissions. The DEF is injected into the exhaust flow, where it provides an environment where catalytic reaction can take place that converts harmful oxides of nitrogen into environmentally harmless oxygen and nitrogen. This is a delicate process that requires that the injected solution be perfect in both quality and blend. Even minor variations in the blend can cause operational problems with both the engine and the aftertreatment system. The bottom line is that failure to add a few dollars worth of DEF when it is needed will result in hundreds or even thousands of dollars in downtime. This process is mandated by the regulatory agencies to incentivize the drivers to maintain a proper DEF level and quality. So what would happen if I let the DEF run out or added something seemingly harmless like distilled water, just to get home? Low DEF supply will cause a series of visual and operational inducements to the driver. Once the terminal D rate is reached, the engine must be serviced by a Kenworth or Peterbilt dealer to restore normal operation. Terminal D rate will only occur as a result of failure to take action in response to DEF level or DEF quality warnings, or if there is a defect in the systems that monitor DEF level and quality. The DEF inducements are explained in detail in the operator's manual and on the decal located on the back side of the driver's sun visor.